Hey everybody. Okay, so just wanted to recap with some stuff that we talked about in class, and go back over like the way that we work these out and getting some of those foundations on greatest common factor. But the first thing we need to know is we need to know what a factor is. Okay, a factor is the number we can multiply. Those are the numbers that you can multiply together to get another number. So, like if you have the multiplication problem 2 times 3 equals 6, well, the 2 and the 3 are both factors. They're both factors of 6, which means you can multiply them together to make 6. I don't want you to think for a minute, okay, what are some numbers that you can multiply together to get 50? Okay, well, if we go to 50 and we're sitting there, we're like, okay, we need to figure this out. I don't know. I know that, let's see here. I know that 1 times 50 equals 50 because anything times 1 in itself is going to equal itself, right? Okay, let's see what else I can do times 50 to find 50. I know that 50 has a 0 on the end of it, which means if I multiply 10 times 5, that's just going to be 5 times 1 with a 0 on the end of it, which is going to be 50. Cool. Okay, let's move on to the next thing. I may know some prior knowledge about change. I know that 2 quarters makes 50 cents. So 2 times, we'll say a quarter's worth 25 cents. So 2 times 25 gives me 50 as well. All of these are factors. They're factors of 50, including itself. Remember 1 in itself? Remember 1 in itself is a factor? So just kind of keep that in mind as we're going through this and we're working with factors. The greatest common factor, well, before we get to the greatest common factor, or before we get into, because the next slide I know is divisibility, let's look at this. The greatest common factor is when we're taking two numbers, we're finding what they have in common, and then we want to find the largest of those numbers that we have in common. So give me 1 second. Okay, so let's say I have two numbers. We'll look at two numbers that are easy to find the factors for. We'll do 6 and 8. Well, we know that we can multiply 1 times 6. We know we can do 2 times 3. And those are pretty much our factors. And then for 8, we can do 1 times 8. We can do 2 times 4. Or we can do 2 times 2 times 2. And these are all factors of both of those numbers. So what we want to do is we want to sit there and think, okay, what is the largest of those two numbers that they have in common? Well, here we have a 2, and here we have a 2. Well, honestly, when we're sitting there, we're looking at them, we're going, okay, well, there's no number bigger than that they have in common. This side over here doesn't have a 3. It doesn't have a 6. But the only thing that we have in common is 2. So the greatest common factor of the GCF is going to be 2. Now I'm going to give you some tools that are going to help you with solving these. And these tools are going to be on the ALDCA Success website that you can go and check out. So let's look at this next one. These are divisibility rules. These are rules that you can. They're basically like cheat codes. They're gonna be the things you're gonna go back to. You're gonna look at. They're gonna tell you, like, if I'm trying to find out if something is divisible, that'll tell me what the factors are. I want to know if 2 is a factor of that number. I want to know if 3 is a factor of that number. 5 is, or 7 is, because those are primes. And when we are doing prime factorization. Oh, I ran out of space. When you're doing prime factorization, what we're doing is we're trying to find all the primes of a number that you can multiply together to make that number. So like a prime factorization of 6, well, 2 is a prime and 3 is a prime. These are the prime factors of 6. The prime factors of 8, we got those. It was 2, 2, and 3. You multiply all those together and it'll make, 2, 2, and 2 again, not 3. There's no 3 in that. Sorry, it's 2. So you have 2 and 3, and then 2, 2, and 2. And the only thing they have in common was the 2. And that's what you're trying to get to find the GCF, is find that prime factorization. Otherwise, you're just going to be sitting there guessing on and on and on what the what it is that, what is the prime of that. On and on, trying to find what are the factors of that number and where are they. What is the largest number that they have in common? It's there'd be a lot of division. That's a lot of guessing and checking. And I reckon you probably don't have a lot of time for that. So prime factorization will help with that. But let's look at some of these things, these tricks that we have on here. And really what I want you to do is I know I put on 7 because it's a factor. I really only want you to start off with focusing on 2s, 3s, and 5s, because you can pretty much boil it down pretty easily once you've got those. So let's look at some of these tools. Let's say the first one says, is the last digit, if the last digit is even. So let's say you've got a number like 48 and you look at the last digit, that's this number. Is it even? Meaning, can you count by 2s to get to it? 2, 4, 6, 8. Yeah. So you can divide that. You can divide that by 2 easily. Okay. The next one says the sum of the digits is divisible by 3. Okay. So I'll give you a number like 36. Okay. And that's a digit. The 3 is a digit and the 6 is a digit. The sum of those two numbers, if I take the 3 and I add them together to the 6, that gives me 9. And you ask yourself, I know it sounds a little confusing here, but you're asking yourself, can I count by 3s to get to 9? 3, 6, 9. Yeah, so I can divide it by 3. Fantastic. I can divide that. Here, I'm going to put up here. You can divide 36 by 3. It's just a good cheat code to kind of know. Don't need to worry about 4. We're going to go to 5. Let's say we have a number like earlier we had 50. And you ask yourself, is it divisible by 5? Well, it's only divisible by 5. Look at here if the last digit is a 5 or a 0. We're in luck. The last digit's a 0. So that means that we can divide that by 5. That'll help us with finding our prime numbers because we can figure out if it's divisible by 2, it's divisible by 5, or if it's divisible by 7. A lot of times what I would do is do 2, 3, and 5, and if that doesn't work, try 7. See? That'll help you. That'll help you with it. So you're not guessing checking so much. All right, let's look at. So I went ahead and blocked out everything except the 2s, the 3s, the 5s, and the 7s. The number 50. So this is a T-chart. And what I do is this is kind of like the same thing as the ladder. Let's say you had 50, and then you were supposed to do like 2 and 25, and then you're supposed to know that you can break that up to 5 and 5 and all that and on down. That's great if you can do that all in your head, but if you can't, you may need a little space to do some guess and check work, and that's what we have over here. So onto the right over here, I'm going to use this as my my scribble area. For you, you may want to use just a sheet of paper to work on. And over here, I'm going to use this as my organizer to help keep my thoughts in check. Okay, so the first thing is I'm going to look at my primes, look at my composites. I'm going to look at that number up there, and I'm going to look at one of those divisibility rules and see if one of them applies. Well, the last digit is even. It's 0. You could do 2. But the one that you're probably going to go to quickly is the last digit's a 5 or a 0. It is a 0. So it's going to be divisible by 5. And so since we've been spending several days working on long division, we have a method for solving this. So you can use one of the other methods. I'm going to use our level 5 method and level 6 method to find my factors. But I'm going to go ahead and do dividing 5 into 50. And I know that 5 times 1 gives me 5. I subtract that. I get 0. I bring down my 0. And then I do 5 times 0. Subtract that, and I'm at 0. So my two factors I have are 5 and 10. Well, 5 is a prime. So I'm going to put it in my primes, and my composite's going to be 10. All right. Then what we're going to do is we're going to go to the next one. We're going to use 10, and we're going to see if it follows one of the divisibility rules up here. Well, yeah, it ends in a 0. I also know I can count by 2's to get to it, but right now we're just going to use the divisibility rules that we have right here, which is it ends in a 5 and 0, just for time saving purposes. 5 into 10. I know 2 times 5 gives me 10, and these are both primes, so I'm going to put them in my prime section. 5 and 2. And once I'm done with this, I don't need the composites anymore because we're wanting to do prime factorization. We want to know what primes multiply together to get 50. And that is 2 times 5 times 5. All right, let's go on to the next one. That is 24. That is just another number. We're going to use this other exercise for this one. Remember, for primes and composites, we're going to look for use these divisibility rules for primes and see if we can divide it. I'm going to go ahead and look at that, and that's at the last digit's even. Look at that, 4. I can count by 2's to get to 4, right? 2, 4. Okay, so I know it's divisible by 2. I know it's an even number. So I'm going to, in my work area, go 2 into 24. And I know 2 times 1 gives me 2. Subtract that. I get 0. Bring down the 4. Okay, and then 2 times 2 gives me 4. Subtract that. I got 0. So here's my factor. Here's my other factor, but I only really want the prime factors. I want to put that prime on the side and the composite number on the other side. So prime's on the left, composite's on the right. Now I'm going to think about it is what can I multiply? Well, I'm at the same rule that I was before, that last number on 12 is a even number. So I'm going to go 2 into 12. Well, I know 2 times 6 gives me 12 because I can count by 2's to 12. 2, 4, 6, 8, 10, 12. I did it 6 times. So I'm going to put down my prime, which is 2, and my composite, which is 6. 6, 2. Now, I got to deal with 6. I can count by 2's to get to 6, right? It's an even number. 2, 4, 6. That's 2 times 3 gives me 6, right? So these are both factors. They're both prime factors, 2 and 3. And I'm done. I don't need this anymore. But I know if I wanted to make a prime, if I wanted prime factors, the prime factors of 24, I know that it would be 2 times 2 times 2 times 3. That would all equal 24. Where I'm going to find the greatest common factor of these two numbers is when I list all my prime factors of 24 and 50. Let's look at the 24. It was 2 times 2 times 2 times 3. Okay, so I'm going to do that for 24. 2 times 2 times 2 times 3. And then we're going to look back at 50. That was 2 times 5 times 5. Okay, so it's going to be 2 times 5 times 5. What do they have in common? Think about that for a minute. Look at that up there on the board. You've got two different lists. You got this list right here. You got this list right here. And the only ones I see right here that they have in common is 2. So the greatest common factor is 2. All right, that's all for greatest common factor and the method on how to solve it. Let's see how you do on the next slide.